We've talked about inheritance before, right? What is inheritance?
Something passed down.
So it's something passed down to a child, right?
Yeah, but in this context, you're extending a class.
Yeah, I'm extending some sort of functionality by passing down what I have to a child, then I'm going to that child extend it. So let's say I had a base class. We'll call it addition.cs. Namespace, we need to blow that up a little bit. Namespace. Public class addition. And inside of here we have one method, right? Public, we'll have two properties, int x, int y, and then we have one method, public int sum, that returns this plus this dot x plus this dot y. Nothing too crazy here, right? But now, like that's nice. Now I want to create something that is called, that takes this functionality and extends it. So maybe we want to add a third number here. Maybe we want to make a class that adds 3 numbers together. What would that look like? Well, I'm just going to copy this.
Why is it giving you split?
Something to be imported.
Where? Over here on addition?
No, I just saw squiggly, so I wasn't quite sure what.
Oh no, it's just catching up with me. So I have a class add 3 numbers. And I'm going to inherit addition. So now I have access to x and y and also sum. So now I can make a new class called, make a new property, prop z, int sum all 3, and return this dot sum plus this dot z.
Do you not have to do a using statement to inherit?
Nope, because they're in the same namespace.
If they weren't, then you wouldn't.
They're both in the same OO level 2 namespace.
Okay.
So the cool syntax here that we want to kind of mention is this colon addition. That's how we're inheriting the parent class.
Now about this, maybe I can see if I go ahead and put this is returned and what does it mean in this context?
So we worked with this before.
Right.
What is our working definition of this?
This means it's referring to something in this scope.
Something in the scope, Dan? You want to add to that?
Yeah, it's pulling a key value usually. No, it's yeah, what he said.
Yeah, what he said. Does anyone else want to add to that definition
So
of
to
this?
me, it's this instantiation of this application is this is related to this instance of this application.
So this is related to this instance of the class, not the application, the class.
Okay.
So this is referring to this instance of add 3 numbers.
So I'm not quite sure what the sum the framework of sum. But if we were to use this, we have to give it 3 numbers.
Yeah.
How do we specify the first 2?
So the first 2, that's a great question. So if we wanted to use this, let's head up back our tree here. Let's head up to addition, right? That has two numbers. If we wanted to specify the two numbers, we'd add a constructor, right? Addition, int x, int y. This dot x equals x, and this dot y equals y. And over here inside of our program, equals new addition, 3 and 5. Total equals add one dot sum. Cannot type it all today. That would be the value of total would then be 8.
Okay. So now,
So now if I wanted to come down here, we now have an error. So let's read this error. What does that error say?
basically, I think you're using sum, but sum now has been redefined to take in two additional parameters.
So whenever we new up a new instance of add 3 numbers, remember whenever we new up an instance of an object, we're calling its constructor, right? Right? We know that from JavaScript, from C#. So whenever we new up the constructor of sum all 3 numbers, we're also calling the constructor of the parent class as well. And the constructor of the parent class, if we recall, takes 2 parameters. So it's saying, hey, whenever we call a parent class, we don't know what to pass it. So now we have to give add 3 numbers a constructor as well. Add 3 numbers, int x, int y, int z. This dot x equals x, this dot y equals y, this dot z equals z.
Okay.
We're gonna have a little bit of red here real fast.
Question.
So we're not done here, but okay.
Okay, then, go ahead.
You notice that we still have the issue, right? It's still the exact same, well, we don't know how to pass it back up.
Same.
So we need to pass this back up. So that base xy is calling the constructor that takes 2 integers on the parent with x and y.
Base is one parent above.
Only one?
The
Yep.
immediate parent.
Yep, it's the immediate parent.
Would you run into a problem? Well, I guess you would have to do the same thing if the parent was inheriting from a grandparent.
Yeah, but that would handle over on addition.
From the parent.
So with base x, is it transferring it to int x
Mm-hmm.
parameter?
Yeah, this is calling this constructor right here and setting the values.
Right, but is it like reassigning them in x and y and that parameter next to it?
What do you mean by reassigning?
Is it taking the value?
The value is going from here to here
Okay.
To addition.
to here, and then it's ending up being assigned to capital X here.
Can you go back to add 3 numbers?
I'm actually going to put them side by side.
When you call base,
Mm-hmm.
is that, or actually, when you call add 3 numbers and you create it, and you've now instantiated it, are you also instantiating addition because you're calling base? So like, is there 2 instances now that are running?
Nope, there's just one. That's that. That's the idea of inheritance. Even though we're implementing and actually using addition, we're still only have a add 3 numbers instance.
My question earlier just got more complicated. So, can you inherit, like you said here, add 3 numbers? If you would say addition and any other, can you the add 3 numbers could inherit from a couple things, not just one?
So yes and no. So you can only inherit from one class. So if we had another class called subtraction that we wanted to inherit, we can't do that. So you can only inherit from one from one class. Okay. Why? Because what happens? There's a whole bunch of reasoning behind it, but multiple inheritance allows for us to create complex trees of inheritance structures that leads to really janky code with rules that we just don't want. So in order to avoid all that complexity, we're like, hey, no. Because really what happens if you do multiple inheritance, a situation where you have a parent A, all right, then you have that has a parent B and C, then you have D. So if these both have a method that implements the same thing, you say that this has a sum method, and this also has a sum method, and this also has a sum method.
Do you know the signal which sum?
Yeah. If I call d.sum, which one wins?
Yeah, I got it from base because now who you're calling if you have
Yeah.
2 or 3 on top.
Yeah.
So base is referring to.
Yeah. So this is the classic problem of why multiple inheritance doesn't work. But what?
Is that where interfaces come in?
Exactly. You can implement many interfaces. So we can think of addition as a parent class right now. All right. That it's in our little diamond there. We can think of addition as our parent class, as the A. But this provides some functionality that we want to inherit down into the children. To get around this idea of multiple inheritance, what we have is something called an interface. Now we talked about interfaces before briefly a little bit, just kind of out in the air. What is a good working definition of an interface?
Contract.
It's a contract. It is something that we define as, hey, we don't care how you implement this function, we just want you to implement it, and that's it. So let's create a new interface here. Let's call it iadd. Namespace, oop level 2, public, interface, iadd. So you see how we have iadd there. That I is a naming convention side of C#. All your interfaces should begin with I. That's how we know that it's an interface. IEnumerable should be ringing bells right now. So we want to define a contract that defines a sum method. Okay. So this is just the function signature. What's the function signature?
What parameters you pass to it
And what it returns.
and what it returns.
So we know that it's going to return an int, and it's going to be called sum, and it's going to take int x and an int y.
You don't have to make it public or anything?
Nope. That is an implementation detail, and all the implementation details happen at whatever implements that interface.
So all you're building is the skeleton.
Mm-hmm. Yeah, so all I'm saying is that, hey, this thing has an add, and that's it.
Is there a default to the accessors, or what are they called?
Yes, there is an access. It is defaulted to internal.
Private? Oh.
Yeah. So now over here in my addition, I'm going to implement isum. I add, yep. So now this says it does not implement a sum of two numbers, which it doesn't. It has a sum of one number, or a sum of no numbers. So in order for me to fulfill this interface, I have to add a method called sum that takes two parameters. So public int sum.
So you have a sum there.
Yep.
So that sum is now, wait, that's the
Mhm.
first sum.
Yep, so this sum,
Since you just do, you're inheriting from I add.
so this sum,
There is no sum without parameters in I add?
Nope.
So is that a valid entry?
is it nonsensical a little bit?
Yeah.
But it just goes to say that, hey, if addition is an IAD, it needs to have a method called sum on it that takes two parameters.
It's what?
Since addition now implements IAD, an IAD, remember, is an interface that is a contract that says everything that implements me must have something called sum on it. And that sum must have two parameters.
Oh, some, that's you.
So do you need it for sum? The
Not really.
one that you minimized?
Yeah.
So the first sum is of no value?
Nope. No value.
Okay.
So is addition only like creating that connection between add three numbers and IAD?
Mhm.
It's just kind of like with databases, you're bridging that.
Yep.
Those two with that step in between to kind of make those connections.
Lexi and then Chris.
But you said the first one is the one that has no value to it, but it's the one that's being read right now because it has the two references.
Yeah, so let's change that.
Okay.
That was my question.
I was
Yeah.
gonna say, when you call it, which one does it call?
Yeah, so let's change it. Let's get rid of the one that doesn't matter anymore. Let's get rid of this.
Well, the first one,
Do that again?
You just delete it.
I just deleted
Yeah,
the old sum.
That was the one that was being called before because it was
Yep.
above it, but since they're exactly the
yeah,
same.
but,
So, like-
it's not that it doesn't, I mean, it doesn't matter because it doesn't do anything, but you can still reference it. It knows which one, you know which one you want, so therefore when you instantiate that,
Yep.
you're getting that, you
Yeah.
determine which one you want.
Yes. So now let's use this new sum down in the child class now. Because if you recall, this child class depended on sum being there. So now instead of this sum, we just need to pass it this dot x and this dot y.
And then not do the base. Or you still need, well.
It's still this, because remember, add three numbers is an addition.
So when you say this dot x, you're really saying, addition dot x?
Really, yes, we're referencing the x property on addition that we're inheriting.
From base.
Wait, what?
So like usually when you say this dot, it refers to itself, like it refers to its own class,
Yeah.
add three numbers, but in this case, since you're inheriting from addition, you're actually, when you say this dot x, you're not saying this dot x for add three numbers, you're saying this dot x for addition. And then the base, when you pass through x and y, is how addition gets those values.
So this is pointing to addition, not to.
This is pointing to add three numbers, which is pointing to addition.
The signature is pointing to?
What's on your mind? Say it.
So where's the original sum? Where's the first sum?
Gone.
So where do we define what sum is?
Up here on addition.
Okay, so that's referring to addition.
Mm-hmm.
So anywhere that refers to, that uses sum is referring to the addition, which is just return x plus y.
Correct.
So why do you need the int x, int y on the add three numbers that we had? Since you already have sum,
Right here.
why do we need to add that if you already have sum defined right there?
So the question is, why are we saying this dot x, or why are we saying this dot sum, or why are we saying this dot?
Why are we saying this dot x, this dot y? Because we already have this dot sum, where we already define that sum is x.
Because we're actually doing the addition there. We're actually.
I think you're saying like why before you could just say this dot sum and not pass any parameters in, and it would
okay.
still add them, so long as you made a constructor of addition.
It would
But-
still do x plus y because that's what
But it's
sum
because
was.
in IAD, if you go there, you have to pass through. It requires you to pass through two variables, int x and int y. So you need to now you need to pass through stuff, whereas
Mhm.
before you didn't.
Okay, well where is I add coming into?
Addition.
Your inheritance.
Yeah. Addition implements IAD. This is the most abstract 45 minutes of the entire cohort. And we're not done yet. So let's take a short 5-minute break, refresh ourselves, and come back and talk about dependency injection.
Can
At 10:15, we're back.
you touch on overriding?
We will.
Okay.